Hi, sixth graders. This is our last video and our last lesson for Unit 5, which is solving proportions. We, at the end of this video, want to be able to identify proportional relationships and being able to solve proportions. So a few things about proportions. Two quantities are proportional if they have a constant rate or ratio, and proportional relationships have the same unit. So I want you to make sure you write this word, proportion, into your notebook, which says an equation stating, a proportion is an equation stating that two ratios or rates are equal. So comparing two ratios that are equal. So we can see 1/2 equals 3/6, 8 feet over 10 seconds equals 4 feet over 5 seconds. We can see that these are equivalent ratios and these are equivalent ratios. Cross products are when we multiply. So you want to just write down cross products, and I'm going to write this differently. This is when you multiply the diagonal numbers in a proportion. And I'm going to show you some examples on cross products, so we're going to skip this right now and go on to problems, and we'll talk more about cross products. So you should have proportion written down and cross product written down. All right, we want to know if these are proportional. So let me go in a little bit here. A carousel makes 4 complete turns after 64 seconds and 5 complete turns after 76 seconds. Based on this information, is the number of turns made by this carousel proportional to the time in seconds? Meaning, is it making the same amount of turns in 64 seconds as it should be in 76? Like, do they have the same rate going on? So I'm going to set these up as 2 different rates. We have 4 turns in 64 seconds. And we want to know if it's equal to 5 turns in 76 seconds. The first thing, one way that we can solve this is we can compare the unit rates. So 4 turns in 64 seconds, we want to know how many turns in 1 second for each one. So remember, we just take the numerator and we divide it by the denominator. So I'm going to do 4 divided by 64, and I get, 0.06 turns per second. Then I'm going to do 5 divided by 76, and I get 0.06, but it's 0.065, which is going to make me round up to 0.07 turns per second. Let me just double check my 4 divided by 64. So we can tell that they are actually not equivalent, even though it's really, really, really small numbers, but they are not proportional. The other way, which is, we're going to use this strategy more often, and the other way is we're going to compare them by using the cross products. So I'm going to rewrite this. 4 over 64, 4 turns over 64 seconds is 5 turns over 76 seconds. And notice that I have my 4 and my 64 go together, and my 5 and my 76 go together. So I have 4 with 64, 5 with 76, and then I can also see that I have turns on the top, seconds on the bottom. So when I set up a proportion, I have to have the same units on the top and the same units on the bottom. So we're going to compare by using cross products. So what I'm going to do is I'm going to multiply my diagonal numbers, which are my cross products. And I'm going to do 4 times 76 and I'm going to do 64 times 5, and I'm going to see if they're equal. 4 times 76 equals 304. 64 times 5 equals 320. They are not equal, which again confirms that they are not proportional. Okay, let's look at another one, or a couple more. Let's do one more together, and then you're going to do one on your own. 60 voted out of 100 registered, and 84 voted out of 140 registered. So let's set them up as proportions. 60 voted over 100 registered. My 60 and my 100 are together in a rate. And then 84 voted over 140 registered. 84 and 140 are together, and then notice I have my voters and my registration. If I flipped it and I had registration on the top and voters on the bottom, you're still going to get the same answer as long as they match up on the top and the bottom. Now what I'm going to do is I'm going to multiply my cross products. So 60 times 140, and then 100 times 84. So 60 times 140 is 8,400, and then 84 times 100, which I already know is going to be 8,400. So they are proportional. You try this last one on your own, or the last one on this page. $12, 16 yards, $9, 24 yards. 12 times 24, 16 times 9, so 24 times 12 is 288. 16 times 9 is 144, not proportional. When we solve a proportion, so when we see a proportion like this and it's missing one of the numbers, then we can use now we know how to use cross products, we can use that to figure out our missing number. So 21 over 5 is equal to C over 7, and we want to figure out what is C. So the way that we do this is we still use our cross products. So we have 21 times 7 equals 5 times C. I know that 21 times 7 is 147, and then 5 times C is just going to be 5C. 5 times something equals 147, or I can just take 147 and I can divide it by 5, because 147 divided by 5 would give me that missing number of whatever C is. So basically what I'm doing is I'm kind of dividing both sides by 5 to get C alone. So 147 divided by 5 is 29.4, which equals C. And then when I always write what a variable is equal to, I always do my variable first. So then I'm just going to rewrite it. C equals 29.4. And then I want to put it in, or just look at it just to make sure. I can see 5 times something, so probably 1.2 or 3 or something gets me to 7, and 21 times the same thing, 1.2 or 1.3, would also get me to 29.4, so that makes sense. 5 to 7, it's getting larger by a little bit, so this needs to get larger by a little bit as well. Okay, let's do another one. 2.6 over 13 equals 8 over n. So I'm first going to take my diagonal that has the numbers. So I look for the cross products, or the diagonal that has 2 numbers, so not the variable. And I'm going to do 13 times 8. And then I'm going to get that answer, whatever it is, and right away I'm going to divide it by 2.6. So basically that's what I'm doing. multiplying the cross product of the diagonal with the numbers, dividing by the last number that's left. So 13 times 8 is 104, and then I immediately do divided by 2.6, and I get 40. So then n equals 40. And this is how I always want to write it. Whatever the variable is, whatever the letter is, equals whatever the answer is, and then we circle it. Let's do one more together, and then I want you to do a couple on your own. So I look at my cross products, and I see this one has the two numbers, so I'm going to do 16 times 3, and then immediately divide it by 2. So 16 times 3 divided by 2, and then I get 24. My variable is k. K equals 24. You do these two on your own, come back and check. So I'm going to do 6 times 5, immediately divide it by 2. H equals, so 6 times 5 is 30, divided by 2. H equals 15. This time I do 10 times 4, then divide it by 2.5, 40, so I know 10 times 4 is 40, divided by 2.5, and I get k equals 16. Notice that my letter matches up with the letter in the problem. That's where I get the letter. Okay, we have an example of a word problem where we need to set up a proportion. For every 18 people who have a sore throat, there are 2 people who actually have strep throat. If 72 patients have sore throats, how many of these would you expect to have strep throat? So I'm going to set up my proportion. We have 18 people with a sore throat, 2 people with strep. My 18 and my 2 together go together, that's why they go here. And then I have 72 patients with a sore throat, X number of strep. We want to figure out this X. How many people would have strep if 72 people came in with a sore throat? My 72 people and my unknown go together. Sore throat, both of them on the top. Strep, both of them on the bottom. And then I solve. And I look at my cross products. 2 and 72 are diagonal from each other, so I multiply. And then I immediately divide by 18. 2 times 72 is 144, and we divide it by 18, and we get 8 people with strep throat. Which makes sense to me because 18, if there's 2 people with strep out of 18, then it makes sense that 8 out of 72 would have it, or 8 people would have strep throat out of 72. If I got an answer like 1 or 100, that wouldn't make sense, and then maybe that means that I set it up wrong. One more problem that I want you to do on your own, and then check your work with me. Salvador can run 120 meters in 24 seconds. At this rate, how many seconds will it take him to run a 300-meter race? So 120 meters over 24 seconds, and then I'm given 300 meters, so that means I put my 300 meters up here and my n seconds. If you set it up like this, 24 seconds over 120 meters, that is fine as long as you have your n seconds up here and your 300 meters down below. You will get the same exact answer, because notice here my diagonal is 300 times 24, and then I divide by 120. Here it's 24 times 300, and I divide by 120. So you would get the same answer. So 300 times 24 is 7,200, and I divide it by 120, and I get 60. So n equals 60 seconds. So 24 seconds in 120 meters, 60 seconds in 300 meters make sense, sound reasonable, so that would be my answer. All right, that is all I have for you on proportions. Have a good night.